SADM is a big project within GSSA. It's a project that's modernising how South Australia is going to compile, manage and deliver our pre-competitive data. So it's actually a huge project, and it's sort of going to be a subject of a talk tomorrow, so I don't want to go into too much here. I'd rather talk about geology. But if you come tomorrow, you'll find out a lot more about this. I'll probably just acknowledge there's Frank Rarity somewhere over there, and Rashid Abdullah. They're actually part of the compilation team. So it's a big project. It's a lot of people in the survey, but they're part of the compilation team, and it's really quite exciting. I was originally asked just to say, from a regional geology perspective, what can we see in the new data? That was my remit. And I think one thing is, it's been stressed before, is we see a lot of detail in the gravity that fits well with previously mapped structures. But you can see where the Kurubi comes down through here, fitting very nicely with the gravity. You've got the Kelowna coming down through here, Tallaringa. So there's actually a nice correlation at the surface between structures and the gravity. But we can actually see a lot more. If you go into this gravity high here, which has been mentioned a few times, you can actually see that the west side is quite a strong gradient. You can see that the top's reasonably uniform, but then you drop off. When you look at this, there's a structure here which I've mapped based on the edge of these units. You can see this is the area that's been mentioned previously by Dylan. Claire mentioned as well. These are the mafic intrusive, Aristarchus, etc., Skews Hill, but they're also the BIF units. So if you map in that boundary, that fits pretty well with the top of that gravity gradient, gravity high, and then you get this gradient going off the side. So there's some really interesting patterns come out. When we think about that in 3D, because we happen to have the seismic line across here, we can sort of start leading the idea that this area here, which is full of mafic rocks, becomes a gravity low. I should go back and just stress that this area here is actually where Challenger and Gulf Bore is. So where the gravity gradient is actually full of metasediments. So far there's been no mapped mafic rocks at the surface or in the mag. As you can see in the mag, there's very few, and no granite. So it's really just purely metasediments through here. Once you get out here, you start to have a low that's got paragneiss and gneissic granites, which you can see through here. And then you go out into this area where you start seeing more mafics again. And this is where Claire made the comment before that this area here actually has chromium prospects. So surprisingly, the gravity high, or where you see the purely metasedimentary rocks, corresponds to this gradient and not this low. And I thought that was quite interesting. When you look at the seismic section, you suddenly get a few more insights that everything's listric dipping towards the west. So it looks like this area here, which is the package of mafic rocks, is actually dipping towards the west. There's probably, this is the seismic line from Tarcoola across the WA. But you can see that this roughly is the extent of that high. And you probably have a package coming down through here which corresponds to that, which is why you get that gradient on the side. So I think that's sort of quite an interesting outcome. We also sort of shown before, there's been quite a few talks talking about, this is one of Dylan's slides, about growth within the Christie domain. And even though no one's used the word, this structure here would correspond to Kurubi, which is the edge of that gravity gradient, but it's also the edge of the Wilgina, which is the core of the, I guess you could call it the core of the Gawler craton, with the Christie gneiss growing off the side. And so you've got this major structure here, you've got these series of structures with different packages, but several of them, the one closest to the protocraton, has got a lot of mafic rocks coming up. So it looks like this Kurubi may have actually channeled mafic magmas up through this package, but it's also likely that we've got something similar happening further out in this area, which would correspond to this part here. So it looks like at 2480, there's quite a lot of this extension's going on, deposition of the Christie, but then you're starting to get these mafic rocks coming in. So it's really a big period of crustal growth. If you look at the MT for the same area, this is that gravity high. Stefan's already talked about this good fit, spatial fit. You can see there's the Kurubi at the surface. There's the gravity high. The dashed line, dotted line here is the northern extent of the Fowler domain. So there's sort of a reasonable fit. It's sort of not quite as good, but it doesn't go too much further. So you've got this fit at the surface, but when you look in 3D, it's quite different. This is that resistive zone that Stefan mentioned just then. You can see, if anything, it's getting deeper towards the east. And if it was related to these structures, you'd expect to see the opposite relationship, where it would be related to the Kurubi. In fact, when we first saw this feature here, there was a discussion about if it's in the hanging wall or footwall of the Kurubi. But we can see now, this is my dodgy attempt to put on the seismic line at different depth slices. This is 6.5 Ks. You can see at 6.5 Ks, it actually crosses the Kurubi on the seismic line. And as you go deeper, it's totally in the footwall of the Kurubi. So this is really, I found quite confusing, a bit surprising. I thought it'd be a nice, simple relationship, but I guess these things never are. Otherwise, it'd be very boring. But it does start to raise lots of questions. You can see, excuse me. So it looks like this footprint here, this resistive zone, may represent a more widespread process. This is what Stefan's alluded to. You can see this is the approximate trace of the Kurubi from the seismic. There's a question of this in the seismic line. We can see there's these old structures here coming down. It doesn't really cross this. So is this perhaps the controlling feature for this resistive zone? Is it something to do with the earlier crustal architecture? So is this quite old? This area through here also has the Muckanuppy anorthosite, other mafic bodies of the younger, so 1700. So could this be a composite feature, composite body? Rather than forming at one time, it's actually several periods of depletion. And the other thing I found quite intriguing is the Kurubis have up to about 80 kilometres of strike movement. But when you look at, this is the 50,000 ohm isoshell, there's no real offset. This is where showing where the Kurubi trace is. You don't actually see offset, and to me, I found that quite intriguing. So the Kurubi movement occurred, or interpreted occurred at 1450. Could this be a young feature? So we've got something big, something prominent, but based on our current understanding, it doesn't really make much sense unless perhaps our current understanding is not right. And so it's sort of, these are things that are just helping us to, I guess, grow our ideas. We've been talking about this area. There's lots of talk about the this gravity feature up here and across the Christie. I'd just like to raise and start discussing the Fowler domain. Now, I found this quite interesting because when I started looking at this data, we could see that there's this crustal growth across the across the Christie. But the Fowler's an odd beast. It's strongly magnetic, as you can see here. Variably density, so it's high in places, low in others. Bounded to the east by the Kurubi shear zone. Previously subdivided into these blocks. So this is work from Teasdale in '97. The other thing that's really quite surprising is it looks a lot like the Albany Fraser. So on the other side in the Yilgarn. So are we seeing a mirror of that type of process? The only difference is that's on the edge of the craton. This is sort of within the edge of the craton. Anthony Reid, a few years ago, did some work when he was with us, and he found that there's a line, and if you go back, Teasdale had a boundary with the Kelowna block, but he had this Barton block that came across. Anthony found, so this would be the Barton, this is the Kelowna. There's actually a boundary that comes through here, where the rocks to the west are magmatic rocks of the Peter Pan supersuite, Tunkilia suite, with contemporaneous metasedimentary rocks. Once you step over this boundary, the Chimpering shear zone, he called it, you start getting Peter Pan supersuite. Oh, sorry, St. Peter suite, too many Peters. So Peter Pan St. Peter suite and the Hilter, and then you also get the metasedimentary rocks have max step ages that are the St. Peter suite. So you sort of seem to have these two packages. He also recognised that these two areas had different metamorphic histories. To the west, it's generally Kimberley extension about circa 1700. This accommodated the sedimentation. These sediments were buried to depths of 25 k's very quickly, and then underwent Kimberley metamorphism. Exhumed during the Kararan at about 1580-ish, and then exhumed during the Kurubi at 1450-ish. If you cross over into this, you see the same sequence of events, but they're younger. So that's St. Peter's Sweet sedimentation and extension and magmatism, buried during the Kararan and then metamorphosed, and then experiences Kurubi metamorphism and exhumed at the same time. So you've got these two quite different histories of episodic crustal growth. And I think that's quite exciting. Basically, the Kurubi is acting as a major structure that's accommodating episodic crustal growth within the Western Gawler. Now we sort of have, the other thing I'd like to just stress is there's been work done previously. We've got where the blocks are being juxtaposed and shuffled round. This is one example. And one thing I would like from the GCAS is you can actually see that the rocks of the Fowler have got these nice sharp intrusive contacts where they cross-cut the Sliphoidian trend. So these aren't tectonically interleaved. These rocks are actually in place in this spot. So this isn't, I said that these episodes of crustal growth, they're not occurring elsewhere and getting shuffled in. These are happening in situ. So basically it's in situ crustal growth within the Western Gawler Craton. And it's focused along the Kurubi shear zone. So the question would be, why do we suddenly see 2850-ish, I've gone blank on my ages now, 2460-ish here, and then down here it's younger. So why do we see a switch? Is it possible you've got this major gravity high, you've got this feature in the mid-upper crust, it can be traced quite a way in the MT. Does that actually form a coherent body of crust that possibly during the Sliphoidian that then resisted this extension? It essentially fixed the Kurubi shear zone. Anything that was going to happen later happened to the south of that. So it's possible that's happened. And then during that extension, you've had sort of simultaneous intrusion of those accommodating shear zones. So if we look at this, we end up with this type of model off the edge. You've seen this model, Dylan introduced it earlier. So you've got the 2480 extension. There'd also be, say, 2440 shortening during the Sliphoidian. We see something about 1700 this is in the western part of the Fowler, where you get 1700 extension, and then 1690 it's shortened. It's interesting, this is the same age that we're starting to see with Alex's talk around Gulf Bore, so it looks like this is quite widespread. 1610's an interesting, totally different beast, and it's something I don't understand. If you look across, there's a Kurubi shear zone. If you take section line AA, it's like the others, it's nice and simple. We're happy with that. But once you get down to this area, we see something quite different. Once you're in the Notes domain through here, which is bound by this line to the north, we actually have this area is full of rocks that are about 1650, 1610. So that's the St. Peter's Suite. So as well as being deposited within this corridor, it's also must be some type of extension occurring or accommodation along here, some type of thinning, and then you've got deposition of the rocks in this area. There's very sparse drill holes, mostly chips, but you get felsic schists, peroxenites. There's a really interesting range of rocks, volcanics. So there's some type of extension going on, but you get deposition. So you end up with this type of thing. So it's not a simple process. Whatever extension occurred across in the Western Fowler also affected the Noits. I will admit I don't understand what's going on then. I also, when I originally drew these and started thinking about this, I tended to think things were going out and back east from an east-west direction. It's east-west shortening, east-west extension, and all nice and simple. Until with the discovery mapping, I'm compiling this area, which is corresponds to about here. It's underneath the arrow. And this is the 1VD. But when you start to put overlays in, if it was shortening east-west, you'd expect to see north-south oriented grain. If anything, it's east-west. And what overprints these are conjugate faults that suggest north-south shortening. So something's happening. No, it looks. I could tell you a really simple story, but it's more complex. As it goes towards the end, it gets become quite complex. But no matter the shortening direction, we still have these 3 episodes of crustal growth along the Karibi. Now, why is this important? I've drawn the Karibi in here in the white dashed line. The mafic magmatic nickel prospects tended to be formed in areas with crustal growth. And if we look at this, this is the Aristarchus area that we've been talking about before through here. We also have this part over here, which is the one that Claire mentioned before, the chromium. But what I find interesting is these 2 new belts have also got, this is the work Western Areas, I think Mithril originally drilled through this area. We start to get nickel prospects forming within the fallow domain at both stages of the fallow domain, even leading out into there's nickel copper prospects out within the Neutz domain, within the mafic intrusive rocks. Some of these rocks are inferred to be Hilteba, but some of them are potentially some Petersweet. So there's actually, wherever we see crustal growth in this part of the world and we see evidence for it and extension, we're starting to get nickel occurring. And I'll just leave it there. Thank you.